We have a particle that is moving along the curve given by x, y, and z. We need to determine the velocity and acceleration of the particle at time t equals to 0 and at time t equals to pi over 2. We also need to determine the magnitude of the velocity and acceleration at any time. So let us begin. So let's say we have a curve and there is a particle that is moving along this curve. At any given instant of time, let us suppose that the coordinate of this particle at that instant of time, let it be point P. So this will be given by x, y, and z. Then, with respect to a fixed arbitrary origin, the position vector of that point P will be given by vector r as a function of t. So that means we have r vector of t given by x I cap plus y j cap plus z k cap, and we are provided with the values of x, y, and z. So x is 4 times cosine of t I cap plus y. So y here is 4 times sine t of j cap plus z. So z here is 6t k cap. So this is our position vector as a function of time. Equation number 1. T could be any parameter, so here we will consider it to be the time parameter. Now we will find out the velocity of the particle. So to find out the velocity of the particle, what we'll do, we'll have to take the time derivative of our position vector r. So that means we will take the derivative of each of the terms on the right hand side of equation number 1. Here I cap, j cap, k cap, these are constant unit vectors. Constant unit vector means their derivative with respect to t will be 0. So we'll only have to take the time derivative of their respective component. So derivative of 4 times cosine of t, so that will be negative 4 sine t I cap plus derivative of 4 sine t, so that's 4 times cosine t j cap plus derivative of 6t, so that's 6k cap. So this is going to be our velocity at any given moment of time. So let's call it equation number 2. Then we'll find out the acceleration of the particle. So acceleration, to find out the acceleration, all we have to do is take the time derivative of the velocity given in equation number 2. So we will take the time derivative of each of the components. So that means derivative of negative 4 sine t will be negative 4 cosine t I cap plus derivative of 4 cosine t will be negative 4 sine t j cap, and 6 being a constant, so its derivative with respect to t will be 0, and this is going to be our equation number 3. So now that we have the velocity as well as acceleration, we'll come to the specific values of the velocity and acceleration at this given time. We will first begin by calculating the magnitude of the velocity and acceleration at any given time. Now that means let's consider equation number 2. So we want to find out the velocity, the magnitude of the velocity of the particle at any instant of time. So this will be, we'll have to take the square root, and within the square root we'll take the square of each of their components and add them to each other. So square of negative 4 sine t, that will be 16 sine squared t, plus square of 4 cosine of t, so that will be 16 cosine squared t, plus square of 6 will be 36. So let's solve this. So we have 16, so we'll take 16 as the common factor, and we'll have sine squared t times cosine squared t plus 36. So sine squared t plus cosine squared t, that's a identity with a value of 1. So we are left with square root of 16 plus 36. This will be square root of 52 with a velocity of approximately 7.21 units per time. So this could be in minutes or second. So here we are not specified, so this will be 7.21 units per time. Now we will find out the magnitude of the acceleration at any given moment of time. So we'll need the acceleration. So this follows from equation number 3. So we have acceleration, its magnitude will be, take the square root, and underneath the square root we'll take the square of each of the components and add them to each other. So we have 16 cosine squared t plus 16 sine squared t. So if we take 16 as the common factor, that will be multiplied to cosine squared plus sine squared t, which is 1. So that means we have square root of 16, and that's equals to 4. So this will be the magnitude of the acceleration. So it will be units per time squared. So that will be the unit of acceleration. Now we will come to the part we'll have to find out the specific value of the velocity and acceleration at time t equals to 0 and time t equals to pi over 2. So let's do that. So we'll begin by determining the value of the velocity at time t equals to 0. So that will be, so we have negative 4 sine of 0, so that's 0. So we do not have any x component. Then for the y component, we have 4 times cosine of 0. So that will be 4j cap plus 6k cap. Then we will calculate the acceleration at time t equals to 0. So we have negative 4 cosine of 0. So that will be negative 4i cap. The y component will be 0 because sine of 0 is 0. So we only have negative 4i cap. Then we'll calculate the velocity at time t equals to pi over 2. So x component will be negative 4 sine pi over 2. So that's negative 4i cap plus y component will be 4 cosine of pi over 2. But cosine of pi over 2 goes to 0. So that means we have 0j cap plus 6k cap. And then our acceleration vector calculated at time t equals to pi over 2. So that will be the negative 4 cosine of pi over 2. So that goes to 0 because cosine of pi over 2 is 0. So we do not have any I component. And then we will have negative 4 sine t. So that will be negative 4j cap. So this is the value of the velocity as well as acceleration calculated time t equals to 0. This corresponds to time t equals to 0, and these value corresponds to t equals to pi over 2.